This video is meant for Mrs. Rose's AB Calculus class, and it is the solution to the adapted 2014 question 1 on the free response section of the AP test, Calculator Active. Alright, we got grass clippings, they're placed in a bin, they will decompose. This is going to happen from 0 to 30 days. And the amount of grass clippings remaining in the bin is modeled by this exponential equation. A of t is measured in pounds and t is measured in days. Find the average rate of change of A of t over the interval from 0 to 30. Indicate units of measure. Alright, average rate of change is very easy. It's just the slope of the secant line, so you need 2 points. We're going to use the x value, or t values rather, of 30 and 0, so those are going to be your denominator. And for your numerator, all you're going to do is plug in 30 into the equation they gave you and 0 into the equation they gave you. So when you plug in 30 and you plug in 0, anything to the 0 power is 1, so this whole expression becomes 1. We get this. Honestly, this is enough for the AP test on the free response. You do not have to simplify, but they did say indicate units of measure. So you need to make sure you have pounds per days. However, if you have your calculator and you have time, you want to simplify, you may totally do that. They're looking for negative 0.197 or negative 0.196 pounds per day. For part B, A prime of 15 is also the derivative of A at t equals 15, or the slope of the tangent line of A at t equals 15, etc. So since this is an exponential function and we haven't taken the derivative of exponential functions, we're not going to do it longhand with like a rule like power rule. You can't use power rule for exponential functions, and we're going to learn more about how to take those derivatives later. But for now, we're going to bring our calculator into the mix since this is a calculator active problem. And I'm going to show you how to take numerical derivatives on your calculator. You go to Math and you scroll down to where it says NDeriv. And if you have a newer operating system, it'll say d over dx and then have parentheses. You should type in the equation now. We got 6.687 times 0.931 raised to the t power, or in this case x. And then you need to tell it what variable you're taking the derivative with respect to. So of x, since it doesn't have a t. And then the number that you're plugging in for x. Press enter. So when you have that, what we're going to write is we have A prime of 15 equals negative 0.164, negative 1.63. And that matches up with our evaluation on the calculator, negative 1.64, negative 1.63. If you have the TI Nspire, you would go to Menu, Calculus, numerical derivative at a point. You have x value, you're using the value at 15, and we're going to type in the function 6.687 times 0.931 raised to the x power at 15, and again you get negative 0.163 or negative 1.64. So then you need to, using correct units, interpret the meaning of the value in the context of the problem. So what they're looking for is something like the amount of grass clippings in the bin is decomposing or decreasing at a rate of 0.164 or 0.163, depending on what you wrote, pounds per day. You need to be careful about your negative signs. Because the derivative was negative, as long as you say decomposing or decreasing, then your rate should be positive. However, if you said changing, then you would need to make these numbers negative. Just make sure your positive and negative signs are correct. For part C, linear approximation is the same thing as the equation of the tangent line. So we want to write an equation of a tangent line of A at t equals 30 and go from there. So we need to have A of 30, the y value, and we need to have A prime of 30. We're going to use that in our equation of the tangent line, and L of y is going to be L of t because it told us that's going to be our linear approximation. We've got our y value. Oops, I have a mistake there. And now that's fixed. So we've got the y value, we've got the slope value, and then we have t minus 30. And because they've asked for just L of t, you need to make sure you move that y value over. You can distribute if you want to, but that is enough, so we can move on to part D. Alright, for part D, they've asked us to use the L of t from last time to predict the time at which there will be a 0.5 pound of grass clippings remaining in the bin. So we're going to have L of t equals 0.5. I'm going to have my equation of L of t equal to 0.5, and I'm going to switch, subtract 0.5 from both sides and add this term both sides, do my subtraction, divide both sides by my slope value, and get 5.05445 equals t minus 30, and then add 30 to both sides to get t equals 35.054 days. We're going to talk about how to score this problem during class. If you have any questions, please feel free to rewatch the video or come see me in Cab Morning or ask me during class. Have a great day.